Morning, folks. This is the next lesson here in acceleration chapter. We're still in section 2. This is velocity with constant acceleration. The question that we're trying to answer here is what is the final velocity when we're considering average distance and the distance. In the previous formula, where we looked at position with average acceleration, we looked at, okay, during acceleration, how far did the car travel? Or during deceleration, how far did the car travel? Now we're looking at this idea where we know the distance, and what we're trying to figure out is what is the final velocity after we travel a specified distance that we already know. Okay, so first of all, the formula is as follows: v sub f squared equals v sub I squared plus 2 times a with a line on it times a quantity d sub f minus d sub I. Sounds like a lot, but you have those guided notes for that accompany this lesson on that particular worksheet. But here's the formula in the yellow box, and I have the variables defined for you. Again, what I need you to do when you're defining variables at like the last question or two of a worksheet that I provide, just write them out just like this. Okay, you don't need to tell them, well, final velocity is equal to da-da-da-da-da. Just v sub f equals final velocity. V sub I is initial velocity, and so on and so forth. The number 2 is just a constant. You have a with a line on it. It's just average acceleration. D sub f is final distance, and d sub I is initial distance. Okay, so we'll do our first example here. This is the example that from the notes that I provided in classroom. I'm just going to go ahead and just do it like I did before and take those examples. I'll put them up on the board for you. We'll walk through them together, and after that, hopefully you have an understanding. As always, if anytime you need to email me, feel free to do so. Especially during the school day, I'm here all day. So don't hesitate to email me and reach out if you need to. I'm more than happy to assist you with your questions. Okay, so first example, we have a car that starts at rest, and its velocity, and increases its velocity at a constant acceleration of 2.9 meters per second squared after the traffic light turns green. It travels a distance of 70 meters to the east. What is the final velocity of the car? Okay, one thing to think about here. When it says that the car is starting at rest, its initial velocity is 0. But again, I still want you to plug that into the equation. So let's plug in those numbers here. We've got v sub f squared, which is what we're going to solve for. We said it's starting at rest, so the initial velocity is 0, so 0 squared plus 2 times a. The average acceleration, if you read through the problem, we have constant acceleration. Average acceleration and constant acceleration are both used interchangeably, so you'll see both those terms. But with these problems, that is provided for you. So the average acceleration is 2.9. Now we're going to multiply that by the distance. It says it travels a total of distance of 70 meters to the east. So your final distance is 70. Your initial distance, since it's not mentioned, it's implied that it's 0. And again, still account for that if you would, please. Okay, we go ahead and we can simplify everything to the right of the equal sign. So we have v sub f squared equaling, this is just 0, so we can just leave that alone. So we're going to multiply 2 times 2.9, and we're going to multiply that by 70. So 2 times 2.9 is 5.8 times 70, and that gives you 406. Now, I don't know if you've read my guided notes yet, but what I did say there was you're not done when you get to this point, all right? Because this is v sub f squared. And if you leave this as is, folks, this number here is greater than the speed of sound. The speed of sound is around 343 meters per second. So you're telling me that under these conditions, with this rate of acceleration traveling this distance, you're breaking the sound barrier? Your answer doesn't make sense. All right? It can't. There's just not enough space for that. You have to think of it in those terms. So we have v sub f squared equals 406. So what I need to do is take the square root of both sides of the equation here. And so v sub f is going to equal 406 is 20.14. All right, square root of 406 is 20.14 meters per second. All right, remember this is velocity, so you need to specify the direction. Here we are, east. All right, you never have to guess the direction. I always provide that for you. So here's your final answer, 20.14 meters per second east. All right, now, some of you may notice that I have a couple formulas written down here. They both involve time. This is final velocity with average acceleration, which was part of last week's assignments. And this is position with average acceleration, which, those will be due next week, next Tuesday night. Now, the reason why I put these formulas on the board is because if you look at the formula here for this current lesson, it does not involve the variable of time. All right? Some of the formulas do, these two do, which is why I put them up here. This formula here, velocity with constant acceleration, does not involve time. All right, just want to point that out to you. And you read the problem, it says nothing about how much time has elapsed. We're not interested in that. We're interested in other factors here. We're more interested now in looking at, okay, trying to figure out that final velocity, knowing that we have a constant acceleration and a certain distance is covered. Okay. Now, I'm going to show you a second example. And so I'm going to go ahead and erase some of this. And there's just basically one more step involved there with that. But you'll see what I mean here. So get rid of this. And remember, what we're finding here is, okay, given all this information, we want to know, again, what's the velocity of the car given the circumstances, given the conditions, the rate of acceleration and the distance traveled. And sometimes the initial velocity here won't be zero. All right, and that's what I'm going to show you here in just a second. So let's say the initial velocity and again, I wrote this out hopefully thoroughly for you in your notes, but I got to use a little shorthand here in the example here on the board. So the constant acceleration of 2.5, and its traffic light turns green. Okay, it's moving to the south. All right, the initial distance. So let me just rewrite this up here, change this last sentence around a little bit so it makes a little bit more sense. All right, so the initial velocity of the truck is measured let's say we didn't measure the initial velocity as soon as the truck started accelerating from 0 up to whatever speed. Let's say we started measuring it at 18 meters. Wait a minute. Yeah. So a distance, initial distance, sorry. All right, so this is an initial. And again, this looks a lot neater in my typewritten notes on Google Classroom than it is here, but you know, it is what it is. So we have an initial distance of 18 meters. From the origin. And the vehicle travels, I'm short, leaving out some words, but you get the idea, to a final distance of 72 meters from the origin. And of course I want to know what's the final velocity of the truck. Okay, so we're going to use that same formula. It's up here, and we'll start plugging in some numbers. So I'm going to solve for v sub f squared, and for our intents and purposes, we're always just going to solve for v sub f squared. Now, one thing we want to make sure of, since we are solving for velocity, make sure that your answer includes the direction term. You don't ever have to guess what direction term it is because I provide that for you. But I ask that you do include it in your answer, and I've tried to show you that on assignments you've already submitted and I've returned to you. So just do take a look at my feedback. I don't type it in there just for my own sake. I want you to read the information I've provided to you so that it helps you along here. Okay, so v sub f squared, which is what we're going to solve for, and that is going to be equal to the initial velocity is 1.2 meters per second squared. All right, actually, we just want to make sure we square that. And then we're going to add to that the constant of 2. The acceleration, again, is 2.5. All right, and we're going to add or multiply that by the quantity of 72 minus 18. Now, some of you can just type all this in at once and come out with the right answer, and that's fine. The way I tend to teach is to show every little step for those of us that actually need to see every little step written out. So what I'm going to do here is just I'll square the 1.2, which is 1.44, plus 2 times 2.5. And again, I'm writing all this out just to be thorough. 72 minus 18 happens to be 54. And of course, that's all equal to v sub f squared. All right, now, order of operations dictate that I do all the multiplication first and then the addition after that. So again, I'm going to bring down 1.44, and I'm going to have 2 times 2.5, which is 5. 5 times 54 is 270. I mean, who doesn't know that off the top of their head, right? And then bring down v sub f squared. And then I'm going to go ahead and add these two numbers. I'm going to get 200, I'm going to say v sub f squared equals 271.44. Now, once again, you're not done because you need to take the square root of both sides. This is v sub f squared. And I want to find the final velocity, so I need to make sure that I have, I'm taking square root of everything that I need to. So v sub f is 16.47 No, I didn't know that off the top of my head. South. All right, 16.47 meters per second south. Now, what these answers mean. So the first example was 20, our final velocity in example 1 was 20.14 meters per second east. And this example, example number 2, the final velocity is 16.47 meters per second south. Now, what does that mean? All right, that means that, again, in conditions where I have a constant acceleration of 2.5 meters per second squared, I'm traveling a distance of 54 meters. Remember, it's 72 minus 18 because in this example I had my initial distance, so I need to figure out that difference, so I get 54. Then once I have that in place, figure out my final answer is 16.47. So under those conditions where I have a constant acceleration rate of 2.5 meters per second squared, traveling 54 meters, and I'm starting out at my initial velocity being 1.44, actually 1.2 meters per second, and then I square that. Then after all that, my final speed, or excuse me, final velocity rather, is 16.47 meters per second to the south. All right. If at any point you have questions, not sure how I did this, when I typed up the notes, I tried to, make sure it was, make sure it's easy to understand. So if I miss something, because it's definitely possible that I might have overlooked something or just not thought something through the way I should have, which that's fine. Just let me know. Like I said, if you have questions, email me. If you email me at 3 o'clock in the morning, I will not answer your email. Look for my email about, later on that morning, about 7 o'clock or so. So if you have any questions, let me know, and keep doing what we're doing here.